Welcome to the openLCA tutorial. This tutorial was prepared for getting familiar you with the concept of lifecycle assessment studies by using the software. In this tutorial, first we will have a look at the definition and characteristics of openLCA software, and then our example case study will be introduced. After discussing it, we will learn how to download openLCA into our computers. And then we will model our system by using our own data in openLCA. And finally, we will learn how to use existing database and compare two different life cycles in openLCA. Let's start with the learning fundamentals of openLCA. openLCA is a free software, so there is no requirement of license cost. Also, it is an open source, that is, everyone can use it. This is one of the most advantageous features of this software. And also, openLCA is used in sustainability and lifecycle assessment studies because of several features. Firstly, it is a user-friendly software, and also fast and reliable calculations can be done by using this program. Also, thanks to the importing and exporting capabilities, users can share their models each other easily. And finally, openLCA provides detailed vision about calculation and analysis results of lifecycle assessment studies and visualize these results. I think that's all about the openLCA. Now let's have a look at our example question. In this question, we need to evaluate the environmental impact of coal power plant to produce 1 MWh electricity. In the table, all airborne emission values are given for 300 MW power plant. We inform that these values are representative or they do not reflect the real case values. It is given also the requirement of coal as 60 tons for 1 hour operation of this power plant. And before jumping to the solution, let's understand the variant of this life cycle assessment studies. Actually, there are 4 well-known variants of life cycle assessment named gate-to-gate, cradle-to-gate, cradle-to-grave, and cradle-to-cradle. Since we do not include the distribution, use, and disposal steps into our example case study, it can be said that our system represents cradle-to-gate life cycle assessment studies. Also, the functional unit of this study that has to be defined clearly in the goal and scope phase of life cycle assessment is equal to 1 MWh electricity production via coal power plant. Therefore, all inventory data should be arranged on functional unit basis. Remember, all of them are given for 300 MW coal power plant. So, we should apply arrangements our life cycle inventory by considering our function unit. To do that, let's have a look at this relationship. According to the table 1, 1.29 kg of carbon dioxide is released when 1 kg of coal is used. The question says that 60,000 kg of coal is used during 1 hour of operation in coal mining process. So, we should multiply this number with the released amount of carbon dioxide, and thanks to this way we can obtain the released carbon dioxide during 1 hour of operation. But this is valid for 300 MW plant capacity, but we need 1 MW. So we should divide this number by 200. Then our unit is changed from gram of carbon dioxide per kilogram of coal to kilogram of carbon dioxide per 1 MWh. And let's make another example for methane in coal transportation process. The released methane amount is specified as 8.1 gram per 1 kilogram of coal. If we consider again 1 hour of operation, 60 tons of coal are needed. And therefore, we should multiply 60 tons of coal by emitted methane amount, which is 8.1 gram. However, this again represents 300 MWh plants. So, we should divide the final result by 300 to find the released methane amount that comes from the coal transportation. This step is valid for all inputs placed in coal mining and coal transportation processes. In the coal combustion, all airborne constituents are given as kilogram per hour. That is, operation time has already been considered for this process. So the only requirement is to change the given inputs for 300 megawatt-hour plant capacity to 1 megawatt-hour plant capacity. In order to do that, we should divide all values by 300. For example, for the particulate matter, release is given as 368 kg for 300 megawatt-hour coal power plant. If we divide this number by 300, we can obtain particulate matter emission as 1.2 kg. Again, this is valid for the other airborne components in coal combustion processes. And here you can see all results thanks to this life cycle inventory arrangement procedure. And then we are actually ready to model our system by using openLCA, but first we should download this software. To do that, let's write openLCA in our search engine. After opening our search engine, let's write openLCA. And you should click this website. This is an official website of openLCA. And now you can see different tabs located above of this page, and here you can see the download tabs. Please click it, and then you will see a page that tells you you should write some personal information to download openLCA. And after entering them one by one, you should click this submit button, and you will be redirected to another page. In this page, there are two options. While the first one is downloading openLCA in a zip folder, and the other one is downloading it with installer. In the second case, if you have already downloaded an old version of openLCA and want to change it, you have to install the old version first and then install the newer version. For this case, let's choose the second option, which is an installer option, and continue to download process. After, click on the setup file and wait. Okay. You can see the language option. In this case, I'm gonna choose the English, and then we can click OK, and then we can click next. You should accept this license agreement, and then we can keep these settings default. And yes, if you don't want to create shortcuts, you can leave blank. Okay, it can take some time, and let's finish the downloading process. Okay, after opening our software, here in the middle of this screen, you can see the welcome page with the different tabs or options. For example, in this tab, you can see openLCA updates. And in the other items, you can find the menus and case studies examples related to openLCA. So, by using these items, you can increase your knowledge about openLCA. And also, you can click this sign in order to close this welcome page. And now, let's have a look at how we can create a new database to enter our own values. In order to do that, you should first right-click in the navigation bar that is found in the left-hand side of the screen and choose New Database. And then you can write the name of database, whatever you can. For example, we can write openLCA tutorial. Okay. And by the way, you have to use the database name that includes at least 4 characters. And after, you can select local as a database type and complete reference data as a database content. You can finalize the database creation process. And then you can see the create database in the navigation bar. If you double click on it, you can realize that there are various subcategories inside it. And let's get familiar them one by one. For example, flows represent the one inventory data relevant to mass flow. For example, in our example case, one emission flow of methane because of the coal mining process means one type of flow. And then processes represent sequence of operation as the name implies. And for example, coal mining, coal transportation, and coal combustion are the main processes of our example case study. And then product systems are the collection of several processes. That is, if the processes that I listed before are combined, then they represent product systems. Also, project component is used to compare two or more results. For example, if we want to compare the environmental impacts that come from the glass and PET bottles, we should use this one. And that is, with this way, several life cycles can be compared. However, in our example, case modeling up to a product system is enough for us. And then we have also indicators and parameters option in the navigation bar. And here we can have an information about social indicators, global parameters, and data quality systems. And depending on your study, you can modify them. And moreover, under the data quality systems tabs, there are two different data quality systems called ILCB and EcoInvent here. In both systems, there are various indicators and scores that define the quality of data. For example, in EcoInvent data quality system, reliability, completeness, temporal correlation are the example of these indicators. Also, there are 5 different ranking scores. For example, while 1 or green color represent the most qualified data in all indicator categories, 5 or red color means the non-qualified data. And then the most important thing in the indicators and parameters tab is the impact assessment method, because it represents a method of environmental impact calculations. For example, TRECI, ILCB, Recipe, Impact 2002 class are the most well-known lifecycle impact assessment methods. And some features such as selected impact categories, characterization factors, and evaluation methods are different from these impact assessment methods, let's say. And again, depending on your study, you can choose one of them. With this way, you can get your results. And then we have also another tab named background data here. And background data actually covers aggregated data sets to form background processes that has no or indirect influence on the production volume. When you create a new database, you can realize that the lifecycle impact assessment methods and background data are not defined well, so you have to insert them by our own. And therefore, let's continue this tutorial with how to download an existing database and import our study. To do that, we should go openLCA website again and click Lifecycle Assessment Data tab located above. And when you scroll down on the page that opens, you will see a website link called nexus.openlca.org. Please click this link and then click Databases tab located above again. And now you will see all the databases. And actually, as you can see there are 2 types of databases which are free and purchased. And in the purchase database, you can see the well-known ones such as EcoInvent. And normally, the inputs found in the EcoInvent database is not free, but the lifecycle impact assessment method of EcoInvents are free. And to download these methods, we should click Browse button and scroll down the page, and we can see the relevant item at the bottom of the page. Then we should click Go to Downloads. But first we should enter our email or username and password that have created during the software downloading procedure. And after you verify your email address via the link that sends to you, you will be directed a page. And normally, you may not be able to see this page immediately because I have already completed this verification process, and that's why I can see this page easily. But after you verify your email address, you can reach this page by clicking just this Downloads tab located above. Then in that page, you can choose Eco Inventory as a lifecycle impact assessment method. And after clicking the agreement components, you can download this file. And then you can go to the folder that you have downloaded items and see the file type is local file. And then we can go to openLCA and right click in the navigation bar, but first we should close these things. Okay, and choose restore database, and then we should find the relevant items that we have downloaded, which is our Eco Event Impact Assessment database, and we should open this file. And here you can see the items in the navigation bar. But you should be careful about that this item doesn't download it inside our defined database. Let's check. Here, as you can see, our impact assessment methods tabs is still empty. So we should first export these impact assessment methods to another location in our computer and then import to our study. To do that, first you should double click the relevant impact assessment methods, and then right click impact assessment method under the indicator and parameters tab, and then please choose export. Then you will see there are different downloading formats here, and you can choose EcoScope impact assessment methods and click next, and be ensured that whether the exported file location is the same with the imported database location by clicking Browse button. Here we should select this one, and then you can select downloaded file that is available in the screen and click Finish. Again, it can take some time. And now we can see all EcoInvent impact assessment methods found in the downloaded file are exported with EcoScope format. Here you can see all of them. And after we complete the export part, now we are ready to import this export database file. And first we should go to our database again and right click the impact assessment method, and please choose the import in this section, and then again you should click the EcoSpot one format and then click, and here we should find our lifecycle impact assessment methods, and be ensure that you choose all of these impact assessment methods, and then you can click next. You can keep these settings as default and click Finish. And here we can see all the imported lifecycle impact assessment methods under the impact assessment methods tabs in the navigation bar. Now we are ready to model our system by using the inventory data that we have calculated or arranged already. First, we should enter our input values into our database. If we double click the flow arrows here, we can see elementary flows: air, resource, soil, and water flows here, and some items have already been defined in our database. If you have any new flow in your life cycle study rather than these defined items, you can insert them by right-clicking the Flow tabs and select the new flow. However, in our example case study, the listed items in elementary flow option are enough for us. And for example, the data found in the emission to air parts under the elementary flows tab can be used in coal mining processes actually. Normally, coal power plant is located in low population density area here. We can find the required air emissions data in this part. For example, carbon dioxide types are located here. We click C and we can find the carbon dioxide types here. And remember, we will use these data in our system modeling. To do that, we should create 3 different processes called coal mining, transportation, and coal combustion by just right-clicking the processes component and click New Process. And we can write the name of processes. For example, in our case, we can write coal mining, and we should choose the Create a New Flow for the processes option. And then, as a reference flow property, we can select mass because our primary raw data is given on the basis of 1 kilogram coal consumption, but then we should convert it by considering our functional unit. As an alternative way, we can directly select the energy here at this point as a reference flow property and then continue to our process. And actually, let's follow the second alternative by choosing the energy as a reference flow property. And then we should click Finish. And here you can see the general information page of our coal mining process. And again, depending on your project, you can define the geographical location or the other information such as data quality. For example, you can select EcoInlet or ILCD data quality system. However, inserting the inputs and outputs are the most important step at this point. To do that, you should click the Inputs, Outputs tabs located at the bottom of this page, second tabs here. And then we can see that coal mining is located in output parts and the amount is equal to 1 megajoule. But our functional unit is equal to 1 megawatt hour. So we should change the unit of it by just clicking this frame and choose megawatt hour by using the menu bar. And then inputs for the coal mining operations can be mainly energy and coal materials. And the energy is required for vehicles in mining operation, and of course these vehicles can use fuels. And in our inventory data table, the airborne emission values that comes from this fuel consumption are defined, so we can just enter these emission values as an output. But apart from all these, it is sufficient to enter coal as input for our coal mining process. And let's start with inserting the input part. To enter coal as input, we have to double click it in input part. And we can find the coal in resource part here under the elementary flows. And again, we should continue with the in-ground part. Here we can find coal. And we should double click after we find the coal, but at this point we can choose this coal type unspecified, and here you can see the coal as an input. Then we have to enter a value that represents the required amount of coal to produce 1 megawatt hour electricity. This value has already been defined in the question as 60 tons, so we should enter this value into our database. Okay, apart from the flow amount, and units, we can also define the cost, uncertainty, and also data quality parameters uh, of our inputs. For example, by clicking the cost and revenues frame and choose the edit, we can see the page that is related to the price of our input. And as another example, we can also define the data quality of our data by clicking the data quality frame and then click the edit option. But here we have encountered some kind of error because we didn't define any data quality system in the general information part, and that's why we should first define this data quality system. In order to do that, we should go back to general information part, and then in the data quality, we should select the data quality system. We can choose the eco invent, for example. And now we should go back to inputs and output parts, and then click again the data quality cell and edit. Now we can see the pedigree matrix for our data quality. And actually, we can use this option by clicking the relevant cells like this. And the meaning of cells or these pedigree matrix can be explained. For example, if we collect our data based on our measurements and also they are all are verified, we can select the first cell in this row. But actually we will not use this option because, as I said before, our data is arbitrary, so there is no need to use this type of data quality option. And that's why let's continue with our processes by entering our output values. And actually we should again double click the output parts, and we should choose the relevant items listed are table 1 in our example case questions. And actually we should choose the elementary flow and then emission to air part. And again we should continue with the low population density part because you know the coal power plant is located on a remote place and no one lives in that region. And maybe at this point we can use filter option. We can write the carbon dioxide here. And then please be careful, the results represent the high population density, but we want to choose the low population density. That's why we should continue with this part. And here you can choose the carbon dioxide fossil. That is the most suitable option for our case study. And then again we have to enter the exact emitted carbon dioxide emission for the 1 megawatt hour electricity production from coal power plants. And actually we have calculated it as 258 kilogram. So we should insert this number in the amount unit for carbon dioxide. And let's continue with the other product, which is oxygen. Let's try to find it with the same way. Elementary flows and emission to air, low population density, and we should write oxygen. And here, under the low population density. And again, we should change the amount. And actually, I'm gonna continue with adding all of these outputs. But to save the time for this tutorial, I'm going to skip that part. And then I'm gonna continue with the final result. Here you can see all relevant processes with the relevant inventory data. For example, this is for coal mining. I've already inserted these output values, and this is for transportation. And finally, this was prepared for the coal combustion, like we did before. Actually, there is nothing different in the transportation part. But let's have a look at the coal combustion part detail. In this case, the first two items have been entered as an input for coal combustion, as you can see here. When you create a process, you can see them in the flow tabs here. So we can easily add them as a flow in our coal combustion process. With this way, the relationship between processes can be made easily. Since we have already equalized all units based on our functional unit, there is no need to change these units and amounts here. However, if we need to change for other case, we can enter the relevant number directly, or we can use parameters options located below of this page here. And in this scenario, we can define a name and number in the input parameter table by just one clicking here. Okay, we can give a name, for example, let's say input, and let's define a value as 2, for example. And then we have to come back inputs and output stubs and write the name of this parameter into the amount of field. For example, we should write input. With this way, we define these parameters here, input parameters, into this. This is an alternative way, but in this case, there is no need to use this option. And then the other outputs of coal combustion processes have been imported with the same method. As I said before, here you can see them. And actually, before developing a product system, we should close our processes, but please be careful that you have to save your processes. And to save your processes, you can also use the menu bar located above. Here you should click File and then Save option, like this. You should apply for all of them. Actually, I have already saved these processes. That's why there is okay. That's why we may not be able to see these save options here. And okay, after you save your project, you can right-click the product system located in the navigation bar to develop our product system, or you can go to your processes and click Create Product System found in the General Information part, like this. But let's continue with the first one. After clicking the New Product System, you can choose the coal combustion as a reference processes. Okay. And as a preferred process type, here we should choose system process because it represents the aggregated versions of processes, unlike the unit processes. Also, if you want to define the cutoff criteria, that helps to reduce the required calculation time and memory of your software, you can use it. But it is obvious that you will lose of detail in your results, of course. And then we can keep the other setting as default and finish this step. And here we can see our product system under the product system tab here. And the first thing that you should do is to check your modeling is true or not. By clicking the model graph tab located bottom of this page, third tab actually, you can see your model. Here our coal combustion process is connected to coal mining and coal transportation process. And after, you can also change the location of process in this page by holding and pulling them like this. It is pretty straightforward. And after we cross-checked our model structure, we can calculate the product system to find its environmental impact. To do that, we should change our tab from model graph to general information here. And here we should click calculate button. And then we should click this yes. And then if you apply any allocation methods, or if you want to partition your input and or output flows of your process to the product system, you can use the first menu bar in this page here. But in this case, we do not have any allocation methods. Actually, the most important thing in this page is the type of impact assessment method. So you should define it very well. And as I said before, it strictly depends on your goal and scope of your study. And let's choose recipe midpoint hierarchical method as an impact assessment method of our study. And here the normalization and weighting sets menu bar is empty because not all life cycle impact assessment methods support normalization and weighting. And also these are not mandatory elements in the life cycle assessment, so in our case we will not calculate these items. And then as a calculation type, we should use this analysis button. However, if your study is conducted for a calculation of environmental impact of a specific area, and you can use or you can continue with the regionalized life cycle impact assessment method. Moreover, if you want to apply Monte Carlo simulation used in uncertainty analysis, you can select this button also. But please be ensured that you have entered all uncertainty factors of your inputs and outputs. In our case, we didn't insert any uncertainty factors, so we will continue with the analysis option. Also, we didn't enter any cost-related data, that's why we can leave blank this option, and then we can click Next button. And there are other settings which are related to the data quality properties on this new page. And you can select the ILCD or Eco-Invent Data Quality System here. And then we can continue with the finish. And we can see our results. And in General Information tab, here we can export our results in different formats here. And also here you can see the 5 top contributors to our impact category and our flow results. By just clicking these buttons, we can save these graphs as a PNG format. Here you can see the format of these graphs or file. And then in the second tab, we can see our inventory results here. And in the third one, which is Impact Analysis tab, and the most important part actually, we can understand that our process has how much environmental impact in different impact categories. For example, in the climate change impact category, 2056 nearly kilogram of carbon dioxide is emitted because of our processes. And in the other tabs, actually, you can observe your results detailed in different impact categories. Well, up to now, we have learned that how to create a new database by using our own data and model lifecycle in openLCA in order to estimate the environmental impact of our system. But now we will have a look at how to use existing database in openLCA software and compare two different life cycles that have already found in this database. To do that, let's start with downloading the database that we have done for the Eco-Invent Impact Assessment method for our example case. Please go to openLCA Nexus website and click the Databases tab located above. And then in the Free Databases part, you can download Agribels by just clicking the small Browse button. And then you can download the last one located at the bottom of this page. Again, you should log in to do openLCA Nexus system. And here you can select the inventory databases, which is Agribels 1.3. And also please do not forget to select the suitable Eco-Invent Lifecycle Impact Assessment method. And after accepting these items, you can download all the related materials here. Now, let's import these items into our software. Actually, we have already downloaded Eco-Invent database into our software, and that's why I will not repeat this step again. And I will just upload the Agribels database. In order to do that, again, we should right-click the navigation bar and choose Restore Database, and we can select the relevant database here, and then click Open. Then we can see our database in the navigation bar. If we double-click this database, And also if we continue with the indicators and parameters part, we can see that again our impact assessment method part is empty, and that's why we should again the relevant lifecycle impact assessment methods first export, and then we should import these database again. Actually, we have completed this step before, and therefore I'm gonna skip this part very fast. First, we should export it in an EcoSpot format, and let's check they are all in the same folder or not. Okay, then we can finish this exporting step, and the next step will be the importing these database, of course. And let's choose import, and again we should be ensure that all of these impact assessment methods are selected, and here we can finalize our step or procedure. And here you can see the all relevant impact assessment methods here. And then in this part of tutorial we will compare the two different chemical fertilizers using the existing data sets given in our database. To do that, let's check our database detail. Here first we should click the processes, and then continue with the agriables, and then chemicals, and then fertilizer sections, and then transformation. And after the transformation section, we can see all inorganic fertilizers given in this database. By just double clicking any of them here, we can see all the details of these inputs, for example, inputs and output materials of this data. And in this tutorial, we will compare the life cycle of two fertilizers named ammonium nitrate and urea ammonium nitrate. And since they have already defined in the process tab here, we can directly build product systems by right-clicking product systems tab in the navigation bar here, and click the new product system. And then, following the same steps, we should find the relevant fertilizers. For example, we should continue the fertilizer part transformation, and we can select the ammonium nitrate. Okay. And after keeping the other settings constant, we can finish developing a new product system for ammonium nitrate. And here we can keep the target amount as 1 kilogram. The important thing for the comparison of different life cycle is using the same functional unit. Otherwise, it will not be logical to compare two items such as 1 kilogram of ammonium nitrate and 2 kilogram of urea ammonium nitrate. And then the next step will be to create another product system for urea ammonium nitrate by using the similar steps. Okay, we should find urea ammonium nitrate and just click finish. Here we can produce the another product system. And now we can see the new product system for urea ammonium nitrate with the same target amount and unit. And in order to make the fair comparison, we should keep these units same. And now we can create a new project by just right-clicking the project tabs located in the navigation bar again and selecting the new project option. Actually, we can enter a name. For example, we can write comparison of, let's say, fertilizer, and we can click finish. And here, for our case, you can see the project setup here. Now we should select the lifecycle impact assessment method here. In this case, again, we can use recipe midpoint hierarchical method. Let's find it here. Okay. After selecting it, you can see also the impact categories that will be considered here. For example, climate change, freshwater ecotoxicity, and etc. And then we have to enter the product systems that we want to compare. Therefore, we should double click in this area and choose ammonium nitrate first, and then we should choose urea ammonium nitrate with the same procedure. And then we can also change the name of these options by clicking the name cell, for example. Again, we can write ammonium nitrate, and here we can write urea ammonium nitrate, and OK. And then if we go to the report section located in the second tab, we can see that we can edit the items given in the report. And actually this part is about what results we want to see in our report and how. And let's keep these settings constant. And now we can go back the project setup and click the report button. And here you can see the report that shows your all environmental impact results in distinct impact categories comparatively. Here, this is your results. Also, you can see here the single impact indicator results. You can change this impact category from agricultural land occupation to, for example, human toxicity or metal depletion, and etc. And also then you can see the another results for which is related to the process contributions. Again, you can change this option from agricultural land occupation to, for example, ozone depletion. And finally, here you can see all the results in just one bar graph in this relative results part. And for the comparative life cycle assessment studies, it would be better to use this type of graphs to see all results in just one figure. In our example case, it can be said that the environmental impact of urea ammonium nitrate is higher than the ammonium nitrate fertilizer in all impact categories. As a conclusion, we have discussed the fundamentals of openLCA software in this tutorial video, and then learned how to download openLCA. And then we model our example case study system by using our own data in openLCA. And finally, we learned how to use existing database and compare two different life cycles by producing a report from an openLCA. And I hope the information provided in this tutorial guides you about the lifecycle assessment practices with openLCA software. And if you have any question, you can get in contact with me via this email address. And as a concluding remarks, lifecycle assessment is a valuable tool that will help make safer products for the people and more sustainable solutions for the environment. Good luck with your studies and have a nice day. Bye-bye.